Good afternoon, everybody, and welcome to this afternoon's webinar on Introduction to Life Safety Systems, Connected Fire and CO Detection. My name's Ryan Harding. I'm the Learning and Development Manager over at Hispec Life Safety and Housing Solutions. We're with Hispec now for around about a year, and I look after their training academy where we are delivering life safety and housing solutions trainings to the electrical contractor network via our CPD accredited courses. Today's one being in connected fire and CO detection. If there's any questions as we go through, if you just submit them into your question box and we will address those at the end of the session all in one go with you guys. And until then, I'll speak to you a little bit open when we get to them. So here we go. So a little bit about Hispec before we start. So Hispec as a business, we were established in 2002 with our first full-time member of staff, a lady called Pauline, who actually still works for us, which is amazing. Over the years, we've also then grown significantly, taken on different areas from lighting, connected fire and CO detection. And in 2023, we're established as one of the Times Top 100 fastest growing companies in the country. At that time, we had 18 employees, and now we are up to 38. As a business, we like to use a target market approach, getting our goods into the hands of contractors via the wholesale network, so that our goods are being fitted by the experts on the tools, for want of a better phrase. And one of the key things we look at is value addition. So making sure our products are, a competitively priced product with all the same guarantees and warranties as any other product on the market. So the product you're fitting is a high quality product at a competitive price. And those products are all developed in-house at our offices over in Chorley, from where we get our technical team working on the latest innovations, creating the developments to send away for manufacture. We also partner with various trade associations across the country. Many of these on screen you'll be aware of. So we are members of the LIA, FIA and FPA. We work with the EDA, associate members of NAPIT, the MPBA, the Modular Portable Build Association, as well as being registered members of the ECA and business members of the ASCP. So we link with these various trade associations to keep us up to date with all the various things going on in the market and to make sure that we keep our training and our product up to date with the latest innovations. So let's start in with our training now. So how do you define life safety and what is a life safety system? So ultimately, when it comes to life safety and fire detection, it's heavily regulated in the UK, and it's imperative for landlords and property owners to ensure they have the correct protection in their property, protecting the inhabitants of that property. For homeowners and people that own the building that are living in a domestic dwelling, the responsibility is more on themselves, so those regs are a little bit more lenient. However, there's still a regulation in place where that protection should be available. So, what do we classify as a life safety system? So, when we think of life safety, it's there for one reason and one reason only. That reason is to prevent the loss of life or serious injury. So it goes far beyond just the length of fire detection, heat detection, CO detection. It is anything in place to help prevent that loss of life or serious injury. So it can be emergency lighting with escape route plans and fire evacuation plans, loss of life prevention devices, evacuation alerts, life-saving devices in a building, or various safety devices you'll find around a building. So when it comes to life safety, it falls under one big umbrella. However, we are focusing today heavily more on the domestic fire and CO protection. So the importance of connected fire. So why is it important? So when it comes to connected fire, realistically, you're only as good as your instincts if you haven't got connected fire protection in your property, which is one alarm sounding all the alarms in the property when it detects an incident, whether this be a heat rise in the kitchen or smoke in the areas of the house that trigger the alarm. The important thing is, if those alarms are connected and you're asleep upstairs and you have an incident downstairs, then the alarms upstairs will go off at the same time as those downstairs alarms, giving you the best chance of A, evacuating the building safely, or B, checking if it's a false alarm, somebody's burnt the toast. Normally in my house, that's the case. However, without that interconnected fire, you are only as good as your instincts, i.e. one alarm not connected to the others going off, you are very reliant on whether or not you actually hear it go off. Now, there are some reasons why this is important. So in 2023, the government actually sanctioned a report through the Fire Incident Statistics Report with the fire services to look at how many domestic fires there were in the UK. And there was in excess of 39,000 building fires in the UK in 2023. The actual number was 39,045. Now, from that 39,000 plus building fires, there was over 6,000 non-fatal minor injury casualties and 2,700 hospital treated casualties. From out of that, there was actually 208 fire-related deaths. Now, that may not seem like a massive number when we link it to 39,000 building fires. However, I think we can all agree any death from a building fire this day and age is one death too many. Also, that then links to response time. So the question was asked of the fire brigade, what is the average response time in the UK from the point of call out to a domestic fire incident? And that average response time for the UK is 9 minutes. Now, 9 minutes, it's pretty quick, to get from one place to another house, an average of 9 minutes is quick. But I think we can all agree that depending on the size of your building, getting from upstairs bedrooms to the outside, 9 minutes is quite a long time and it can be done quite quickly. So without that connected fire giving you that early warning, you are in a situation where quite quickly you could become trapped. So what are the British standards that govern fire detection in the UK? One of the things I've put into this webinar this afternoon is that we're going to have various video content from our guys up in Chorley actually speaking to you guys out on the road about these regs. So the main regs that we look at through British standards in the UK are BS 5839 Part 1, which is our commercial regs, and BS 5839 Part 6 for the domestic. The guys on the video I'm about to play are going to cover a little bit on both of those. And again, any questions, just drop them in the question box and we'll come to those at the end.
Will, take 2.
I'm ready to go.
Take 5.
Does that sound right?
Well,
Take 13.
I always thought I'd be good at this, but not a chance.
BS 5839.1 Fire Detection and Alarm Systems in Non-Domestic Premises. BS 5839 Part 1 is a British standard for fire detection and alarm systems in non-domestic premises. It provides guidelines for design, installation, commissioning and maintenance.
The significance of this standard lies in its ability to accommodate the diverse needs of different commercial premises.
Applicable to commercial buildings, industrial facilities and business places. Allows customisation of fire detection and alarm systems based on building size, activities and fire risk.
The example given illustrates this variability by comparing a simple system with just 2 manual call points and sounders to a more intricate setup involving addressable systems connected to various auxiliary devices, as well as the intercommunicating control and indicating panels.
In essence, BS 5839 Part 1 provides a framework that allows for the customisation of fire detection and alarm systems to suit the specific characteristics and requirements of different non-domestic premises, ensuring that the chosen system is both effective and proportionate to the level of risk in a given environment.
BS 5839-6 is a British standard that provides recommendations for the design, installation and commissioning of fire alarm and fire detection systems specifically tailored for domestic premises.
Unlike non-domestic premises, where BS 5839 Part 1 is applicable, domestic premises include homes, apartments and other residential buildings.
The standard acknowledges the diverse nature of domestic environments and offers flexibility in designing fire alarm and detection systems that suit varying conditions.
Systems include mains power detectors with backup batteries, interconnected via radio frequency or hardwired connections. Options for battery-powered devices suitable for situations where hardwiring is impractical.
This provides a wireless means of communication between the different components of the fire alarm system, offering a more adaptable solution for certain domestic settings.
The flexibility outlined in BS 5839 Part 6 recognises the importance of tailoring fire alarm and detection systems to the specific characteristics and constraints of residential spaces. By accommodating various configurations, the standard aims to ensure that fire safety measures in domestic premises are effective, reliable and well suited to the unique conditions of homes and residential buildings. Different types of detection methods, smoke, heat and carbon monoxide, used in fire and safety systems, and it suggests their combination based on specific environmental conditions for enhanced safety.
Smoke detection. Smoke alarms are designed to detect the presence of smoke, which is an early indicator of potential fire. They are typically installed in living areas and hallways where the first signs of a fire are likely to be detected.
Heat detection. Heat alarms are sensitive to changes in temperature rather than smoke. They are particularly suitable for environments like kitchens, where the presence of smoke from cooking might trigger false alarms in traditional smoke detectors.
Carbon monoxide detection. Carbon monoxide is a colourless, odourless gas that can be produced by the incomplete combustion of fossil fuels. Carbon monoxide alarms are crucial in areas containing solid fuel burning appliances, examples fireplaces and wood burning stoves, to detect the presence of this potentially lethal gas.
The recommendation to combine these detection methods is based on optimising safety measures for specific environments. For instance, in a kitchen where smoke from cooking is common, a heat alarm may be more suitable to avoid false alarms. In living areas and hallways where early detection of a smouldering fire is crucial, smoke alarms are preferred.
Additionally, areas with solid fuel burning appliances like a fireplace may require carbon monoxide detection to prevent the build-up of this silent and potentially deadly gas.
By tailoring the types of detection to the specific characteristics of different areas within a building, one can create a comprehensive and effective safety system that addresses various potential risks.
So, based on the video, it tells us there what the requirements are for BS 5839 Part 1 regs and BS 5839 Part 6 for the installation, maintenance and design of all alarms and detection methods in the UK. But that still doesn't answer the question, what are the best suited alarms for domestic property, whether this be you're installing smoke or heat alarms in a rented property, HMO, sheltered housing, or new builds. Now, we do quite often find in the UK, actually, what determines what alarms and how many are via the categories of fire protection requested via quite often the architect, the builders, or the local government. So you've got generally in the UK 3 grades of fire protection: LD3, LD2, and LD1. And these grades of protection specify really how many alarms go in a property. So, for instance, in an LD3 property, you only require minimum protection. So this is where you'd put protection in escape routes only, which is normally a smoke detector in the hallway and landing. Maybe more than one smoke detector in the hallway if the hallway itself goes further than 7.5 meters, but also any loft extensions, or loft conversions where you might have combustible materials up there. So, for instance, if there's been solar or PV fitted on the roof, it would definitely require heat and smoke in the loft area if that battery inverter happens to be in the loft from a previous install, but also a loft extension where maybe you convert it to a bedroom, or some of the new builds where they make them a 2-story house, removing the loft altogether and putting a bedroom on that extra floor. It would require an alarm for the escape. Generally, you find LD3 to be an existing premises, which is owner occupied. So that normally would require a grade D2 category alarm, which is a battery replaceable alarm. So this alarm interconnected to the rest, however, it can be powered via a 9-volt user replaceable battery, providing that is owner occupied, not rented. The next level of protection is what we see more often in the new build market, which is the LD2 protection, which is additional protection. This is where you're going to put an alarm in all circulation spaces that form part of an escape route. So that could be, again, hallways and landings are always a given, but now you'd be looking at putting protection in a living space, and that can be smoke alarm, or quite often smoke alarm and a CO alarm if there happens to be something like a wood burning stove in that living room for heat, where you would require then the carbon monoxide protection. While it can work independently of the alarms, it would still be required. Kitchens where you'd put a heat alarm, because to prevent false alarms from smoke of cooking, heat alarm would be preferred, and then loft extensions. Now, when it's LD2 category protection, you generally have 2 options here. If this is a build which is going to be a rental property, so a social housing, council housing, or a buy-to-let where it's actually landlord operated rental, that would require a D1 category alarm, which is a sealed battery backup. So an interconnected alarm communicating with the rest of the alarms in a property with a 10-year sealed battery anti-tamper backup, so it can't be removed, keeping that protection in place. If that protection required is going into an owner-occupied new build premises or any other premises, then it can be stepped down to grade D2 again, which would be 9-volt battery replaceable. What we always advise at Hispec when doing an LD2, however, is to always, where possible, fit the grade D1 sealed unit, especially in new builds where we don't know for definite, A, is the person living there going to be the homeowner, or B, is it going to be the homeowner, but they might in a few years' time think about leasing it out and then have to upgrade the whole fire system. may as well do it at the point of build. And finally, you have the LD1 protection, which is the maximum protection. This is where you're going to put a alarm anywhere a fire can start. So again, hallways and landings, living spaces, kitchens, smoke alarms in the bedrooms, airing and meter cupboards that have combustible materials, so boilers, or quite often you might find a consumer unit still in those areas, loft extensions, and any attached garages. These premises are installed in existing and new builds, HMOs with no more than 2 stories, and when it's LD1, it always is required that it's a D1 category protection, grade of protection. So that is a 10-year sealed anti-tamper lithium battery. So LD1 is always the highest level of protection from your smoke alarm. So we keep talking about connectivity. So that is that one alarm triggering all the alarms in the property in sequence. Now, there are various ways in which you can actually trigger this interconnected alarm. So they are either via radio frequency. So radio frequency being an RF module, which is inside a unit. Now, the high-spec alarms do come with that built in. And how that works is you pair those alarms when you purchase them. So they are talking to each other wirelessly, sending an 868 megahertz frequency between each alarm in a self-learned pairing style. This is actually generally recommended in new builds to use the radio frequency, as it doesn't work off a Wi-Fi signal. So the result being you don't have dropout in one room to another because they're talking to each alarm. The benefit of that being, if there's a cut to the cable at any point and the battery has to kick in to pair it, you don't lose that interconnection because of the radio frequency. However, 9-volt cable can still be used, so you can still go for the cable interlink, which is a bit more competitively priced. It's not a massive difference in the high-spec product, but it is a little bit more competitively priced. But that is when you are having all the alarms wired to each other, talking over a 9-volt cable interlink, so that when alarm goes off, the rest still go off as well. Again, working off that self-learned pairing, that communication going down all the way. So generally, domestic properties, you're going to have 2 options. The other areas we look at is part 1, interconnection, which is where you're using the commercial fire panels. So that can be anything from your conventional fire panels all the way to your fully addressable fire panels, or what we're seeing in the market now is that more hybrid look of a panel, which we call soft addressable, which is your 2-wire conventional soft addressable panel, which works off dip switches, where you can actually have the alarms going off, but informing the panel of what alarm is going off where. So that makes it easier for the fire brigade when they come in to know where that issue is, or for the people in that commercial setting to know the alarm going off is, for example, the warehouse or the manager's office, so they can actually investigate and decide, is it an evacuation or is it a false alarm? So talking about part 1, regular requirements, here we have a bit of an example of a standard install of a fire alarm system in a commercial setting. The one that you can see on your left as you look on the screen, the radial system. This is your more common 2-wire conventional system where your cable is leaving the fire panel, heading out down a zone to the end of the line where you put an end of line resistor, and generally you would have the devices across that area making up the zone. This is your standard conventional system where the alert will go off and it will generally trigger zone 1, zone 2, zone 3, zone 4, whatever it is seen as where the issue is, and it is then down to the person to go and find where the incident is in that zone. The other one you might see is the loop or ring wiring diagram on the right-hand side. So this is more seen in the more detailed addressable systems where the cable leaves the panel, heading out round the zone, and then returns to the panel. And for that reason, it's able to feed information back to the panel so you can control the devices more independently. So the panel will know that actually in zone 1, it might be the sound in a particular area that's going off versus the whole area itself being alerted, making it a little bit more easy for the people working there or living there, or the fire brigade coming in to be able to identify where the incident is. Seen mostly in schools, hotels, large-scale environments. This is where you see the fully addressable system versus a conventional system, which is more in smaller installs like shops, bars, cafes, small warehousing areas. So, is there an ultimate solution for a multi-purpose office space? So, we believe there is. The introduction of hybrid solutions for Part 1 regs does help with that ability to be able to give you a lot more functionality over a standard conventional 2-wire system versus the cost of a fully addressable system in an install where you may not quite need that much. So the Hispec 2CAS system is a great option on there, where it offers that ultimate multi-purpose office solution, for want of a better phrase. So it gives full addressability. So you can actually, via the dip switches, name each individual device that's on that actual system, so that you know what device is going off and where. Sorry, guys, it auto skipped. It also then gives you versatility of actually being able to decide whether to run it, wire it in ring or radial circuitry, and that flexibility of the fact that actually you can also retrofit it into current installations. It also has alarm verification, 2048 event history, so you don't need to download the information from the panel. You can look directly at the panel, and the ability to do a zone check, so you can identify if there's any faults within that zone of devices not working. To go into a bit of detail on what that panel is, I'm going to just pass you over now to our videos panel again, which has got a little bit of a marketing video on how that panel works.
Introducing the new commercial fire alarm system from Hispec, 2CAS, the 2-wire conventional alarm system. The 2CAS panel is a single-loop 2-wire conventional alarm panel with the ability to soft address devices in smaller installations. 2CAS uses MK2 protocol, so can run any of our addressable devices. Detectors, call points, interfaces and sounders can all be connected to the same addressable loop. Designed with precision and expertise, our system is built to exceed industry standards, meeting the rigorous requirements of BS 58391 and BSEN 54. With soft addressable technology, pinpointing triggers and faults has never been easier. Our system streamlines identification and resolution, ensuring optimal safety and efficiency. From multiple occupancy housing to large commercial spaces, our system adapts to meet the unique needs of any environment. Whether it's a new installation or retrofitting existing infrastructure, our system offers unparalleled flexibility and ease of integration. The 2CAS single loop panel allows the system to be wired as a 2, 4 or 8 radial circuit. With our sandwich sounder device, enhancing sound coverage is simple and cost effective, ensuring comprehensive alerting without added complexity. Whether it's safeguarding lives or protecting property, our system is tailored to meet your specific needs. Choose from a range of configurations to suit your requirements. Experience the future of fire safety with Hispec's 2-wire conventional alarm system. Contact us today to learn more and secure your peace of mind. Your safety protected.
So that video there just gives you a bit of information on how the panel we supply into the market as part of the Part 1 regs works. One of the key features that I do quite like about that one is that Mark II protocol, the ability to be able to put all of your devices on the one addressable loop versus needing zone and sounder circuits. So that frees up a bit of space and cost in the FP cable, and also is a lot easier for you to install, but then also has the additional sounders. So, you know, it's quite a nice little option there for you guys. Moving on from the connected fire now, I want to have a quick talk about carbon monoxide. Obviously, one of the key things we have in the country right now is we're seeing on the news quite often instances in care homes where there's been carbon monoxide poisoning and different areas as such, where we are picking up on incidents where people aren't really testing their detectors as much as they used to. And the key is knowing the dangers of carbon monoxide. Many people don't actually know the symptoms. So obviously some of the key symptoms of CO poisoning, carbon monoxide, is, you know, that unusual headache that you just can't explain, feeling a bit nauseous and sick, getting breathless, dizziness and collapse, loss of consciousness, and obviously we all know the key symptom which hits the news quite often is not waking up from that loss of consciousness. But the reality is carbon monoxide is a colourless, odourless gas. Now, the reality is no one knows they're being poisoned by it until it's too late, and the importance of having the right protection in that property is key. So how do we stay safe? Well, first of all, we must fit an audible alarm near any fuel burning appliance. That can be a gas stove, fireplace, boilers, water heaters, cookers. And I always say to guys, I mean, how many people have installed things like wood burning stoves into their properties over the last 5 years, certainly since the COVID era, as a way to bring down that energy cost of gas bills? Now, if that wood burning stove hasn't been installed correctly, that could be leaking carbon monoxide back out into the room where the people are actually sitting, watching TV, enjoying their evening. So it's important that these devices do have this CO alarm installed nearby, as well as like gas boilers, gas water heaters, gas stoves, and so on. Also, it's always worth saying as well, if the point of exit for the carbon monoxide, i.e. the flue going outside, isn't directly going outside but may go through another room, it is also worth remembering to put a CO alarm in that room just in case that leak happens further down the route to exit. Another key thing to do is ensure all appliances are maintained and inspected annually, if applicable, i.e. having that contract certainly in a social housing market where we're going in yearly and testing all these devices, but also for homeowners or people living there, knowing the importance of actually pressing that test button regularly to make sure that alarm is actually working and they aren't actually putting themselves at risk. Another key thing is to keep it dust free. The biggest, I guess, danger or enemy of any fire alarm, smoke detector, heat detector, carbon monoxide detector is quite simple: decorating. Dust and paint. People not covering up their sensors on the sides of the actual alarms or around those alarms and doing that, decorating or cleaning, and the dust getting in there, making the alarm not work to its optimal level. So why is it important? Well, for a start, in the UK, 1 in 5 homeowners have never ever had a gas safety check. And there's over 200 non-fatal admissions per year from CO poisoning, which then links to the fact that on average, 40 people a year die from CO poisoning, and less than 20% of people consider CO poisoning to be a cause of a headache at home. Another quite scary one is that over 5 million homes in the UK have unsafe gas appliances. Because we just don't think of the CO poisoning, we think of the smoke detectors, the heat detectors, fire protection. We don't think about silent, colourless, odourless gas. However, with all these instances where we are finding these failings, if you like, from a end user perspective on safety, it asks the question, are the methods of CO detection regulated by law? And quite simply, yes, they are. They are actually governed under Part BS 5839 Part 6, just like the domestic fire protection. While they can work independently and only have to be battery operated, they are still required to be there where there's a solid fuel burning appliance. However, to go into a bit more detail, like I did with the fire detection, I'm going to hand you over to our panel over at Chorley again for a little bit more information on what these regs are from a point of installation and maintenance.
Will, take 3.
I normally don't stop talking, so
Scott, take 2.
I'm gonna start stamping.
Will, take 4. 5.
Government advice underscores the critical importance of properly positioning carbon monoxide detectors within living spaces. According to this guidance, the optimal placement for CO detectors is between 1 and 3 metres from potential sources of carbon monoxide.
This recommendation is rooted in the characteristics of carbon monoxide, an odourless and colourless gas that can be emitted by fuel-burning appliances. By situating detectors within this specified range, the likelihood of early detection and timely alerts in the event of CO leaks is significantly enhanced. This strategic placement ensures that the detectors are in close proximity to potential sources, such as gas boilers, fireplaces, or heating systems, allowing for swift response measures to be taken.
Adhering to government advice on CO detector placement is a fundamental aspect of residential safety, aiming to protect occupants from the potential dangers associated with carbon monoxide exposure. Proper placement of carbon monoxide detectors is paramount for ensuring the safety of occupants in residential spaces. It is advised that CO detectors be installed in close proximity to solid fuel burning appliances such as gas boilers or fireplaces, where the potential for CO emissions is higher.
The positioning of detectors near these sources allow for early detection of any dangerous buildup of carbon monoxide, triggering timely alerts and facilitating prompt action. However, an exception to this rule applies to gas cookers. Unlike other gas appliances, CO detectors are not necessarily required in close proximity to gas cookers. This exception recognises that the combustion process during cooking typically produces minimal carbon monoxide emissions, reducing the immediate need for detector placement near gas cookers. This approach to CO detector placement reflects a tailored strategy, ensuring that safety measures are both effective and contextually appropriate for different types of gas appliances within a residential setting.
CO detector placement and humidity concerns. Placement of CO detectors is critical in areas with potential humidity sources spaces like bathrooms. If a boiler is placed in a bathroom, it's advised not to install the carbon monoxide detector inside the bathroom due to high humidity.
This precaution is rooted in the understanding that the internal components of the detector may be susceptible to damage from the elevated humidity levels typically found in bathrooms.
Additionally, placing the CO detector in the bathroom could lead to false alarms due to the atmospheric conditions. Instead, the recommended placement is outside the bathroom door and positioned above the door frame height. This strategic location ensures that the CO detector remains effective in detecting any potential carbon monoxide emissions from the boiler or mitigating the risk of damage or inaccuracies associated with a high humidity environment within the bathroom.
Close proximity to potential sources allows for swift response measures. Adherence to this guidance is crucial for residential safety and protection from CO exposure dangers.
Prioritising thoughtful and context-specific placement of CO detectors contributes to their optimal functionality and enhances overall safety measures within residential spaces.
So that there just gives you guys a little bit of an insight to the requirements for installation and maintenance of CO detectors in domestic premises. So just to end the session on really is one of the things we got asked recently by a developer was, can we utilise technology to enhance protection from carbon monoxide? And the answer was absolutely yes. With the launch of our BC10 battery carbon monoxide alarm that is probably our biggest seller in the market really, it also comes with a free app called Hispec, and that app is fantastic for being able to download that information from your CO detector. So as opposed to just pressing your test button and knowing that it goes beep, what you can actually do is you can actually set the app to record the device and extract all of that data. So you can look at your sensor health, your battery life, current ambient CO, any CO spikes in the area, times the alarm's been deactivated, so you can see if the actual homeowner has been unplugging that alarm at any point or not. So it gives you all that information for you as an installer to be able to say, well, actually, there's an incident or an issue within the property that we need to address, or simple things like, we can see this battery is getting close to its end of life. We probably need to install another one now before we come back next year. Again, any products from Hispec that you might be interested in learning more about to actually help with your installation and your time on the tools, you can contact Hispec themselves direct and they can give you all the information, and then you can price that up via your chosen method of purchase via the wholesaler network. So all that leaves for me to do is say thank you very much for spending your time listening to me, guys. We've got through that quite quickly. And I will now go and have a look at any questions that are on that panel. So we've got a question here. What is the best location for a CO detector? So there are actually the CO detectors themselves, depending on the room they need to be in. They need to be no more than 7.5 meters away from the nearest detector and within 3 meters of a light fitting. Will the presentation be shared with all in attendance? I believe the presentation has been recorded. Am I correct there, Ian? And that will be available?
Yeah, that's correct, Ryan.
Thank you.
We can make the presentation available to download if people want to download it as well.
Are there any more questions from the panel at all? I've got a question here. Do we get a recording of this training sent to us? I believe Ian just answered that with the recording and the downloadable link.
Yeah, it's sent it.
Donald, you are very welcome. And yeah, if I can be of any more assistance at any point, feel free to contact me via LinkedIn or Hispec, and I'm happy to engage with anyone direct regarding any information, or put you onto our technical team at Hispec, which are far more knowledgeable than me, and with any technical questions that you might ever need. Okay, guys, well, I just want to say thank you very much for attending today's webinar, and hopefully we'll see you on the next one we do in the future.